Hey guys, and welcome back to another video on the channel. In today's video we're going to be taking a look at the Math Methods Paper 1 Tech Free Multiple Choice booklet from the 2021 external exam. This is for the QCAA syllabus. Pretty much with this one here you'll be given a standard formula sheet, and that's about it. Pretty much no calculator, no graphics, anything like that can be used for this test. And yep, for the QCAA syllabus. So let's just get straight into the questions. So there's 10 questions, each of them's worth 1 mark. But yeah, so question 1. We've been given a log equation and we've been asked what is this equal to. Okay, so pretty much what we need to know is our standard log laws. Now the first thing I can see straight up here is 2 log 10 of x. We can pull that into here and make that a power, so we can rewrite that as log 10 x squared. So here we're basically having log 10 x squared subtract log 10 3x. Now if we're minusing two logs, and notice they have the same base here, that means we can write it as a single log, but it'll be the first log divided by whatever's on here. So what I mean by this, it can be rewritten as log 10. It'll be this x squared divided by whatever is in here, so it'll be 3x. Okay. Now we can see here we have two x's on the top and one on the bottom, so we can cancel one here and that one there. So this can be written as log base 10 of x over 3. And we can clearly see that's equal to a. Okay. Now these other ones here, this first one here wants you to pretty much, when you're subtracting, to give a very similar thing here, and these other two are just fill answers, but the correct answer is a. If you have any questions about the first one, leave something in the comments and I'll try my best to answer it, but we'll head down to the next one. Okay, so the table shows the time a technician has spent servicing photocopiers. Okay, now notice here we've been given frequency and we've been given a time interval. Okay, now this symbol here means it is between 0 and 5 minutes, but it's not including 5 minutes, so it's like 4 minutes, 0.99 minutes. Okay, so it's not including 5. This is including 0 because of that symbol there. Okay, what is the probability that a given service required at least 10 minutes but is less than 20? So here we want to know, alright, we have 10, it's including 10, and it is less than 20. So we're trying to look for this interval here, okay? Now we can clearly see this is built into pretty much this middle section here. So we'll be including this and this, because notice here, it's including 10, but it's not including 20. So this little interval here is literally the exact same as this. So between 10 and 20, they've just also included the 15 as a separate interval. So here we would add these two together, so that'd be 70, but we need to divide it by the total amount of frequency, because notice it's the word probability. So here you have to add this all together. So that'll be 10, that'll be 30, then that'll be 60, that'll be 100, so there'll be 200 in total. So the answer is 70 over 200. Now this question is non-calc, so you have to work out this decimal roughly by hand. So here you can cancel out one of the zeros, so you have 7 on 20. Now here, we have no idea what this is, but we can compare it to something else, okay? Now, this is definitely not 50% or bigger, so I know for a fact it's not that or that, okay? Because here, 7 on 20 is going to be significantly less than 10 on 20, which is about half. That would be 0.5. Okay, so here it's almost 0.5, but it's going to be a bit bigger than 15%. Another way we can back this up is we know that 8 on 20 would be 0.4, and we know that 8 on 20 is only slightly bigger than 7 on 20, and the answer closest to 0.4 that's less than that would be B. So that further backs up why B is the correct answer. Okay, that one's too small, and those are too big significantly. Okay, if you have any questions about this one here, leave something in the comments and I'll try my best to answer it. Alright, question 3. Determine the integral of 10e to the 4x dx. So here, when we're integrating something like this, we need to divide by the derivative of our inside function. So this integral would be 1 over a e ax plus c. Okay, so here it's the exact same thing. It's 10e 4x dx, but we have a constant at the front. So here we can take the constant at the front and we just have this integral here. Okay, so when we're integrating just this in the yellow, we're writing the same function except we're going to divide by the derivative of this. Now the derivative of that would be 4. So our answer would be 10 over 4 e to the 4x plus c. Now 10 on 4 is the same as 5 on 2. So we're looking for this answer in our multiple choice. Okay. Now you can clearly see here, we can see what they've done here. They've tried to do a power rule here, but that's incorrect. That is also incorrect. They've multiplied it instead. They've differentiated it, and they wouldn't near C, and that's our correct answer there. So the correct answer is C. If you have any questions about this one here, leave something in the comments, and I'll try my best to answer it. I'll probably just say that moving forward with any question rather than just saying it after every question. Alright, so question 4. The second derivative of a function f of x is given by this, and we're given an equation for the second derivative. Now remember, the second derivative describes the first derivative's rate of change, okay? The interval on which the graph concaves up. So a concave up is when you have the curve like this and the gradient is turning around like this. So when it's going from a negative gradient to a positive gradient, okay? So here when the rate of change is negative and turns positive, okay? Now we need to know when this is true. So here, if it's going from a negative rate of change to a positive rate of change, the second derivative must be positive here, okay? So here, the interval on which f of x is a concave up, we've been given an interval for x, okay? So we need to know, alright, what x values makes this positive, okay? So looking at this guy here, we have a couple options involved, okay? So this has to be positive overall. Now, I will not accept x as a negative value, or x is less than 0, or less than or equal to 0, because the negative would get cancelled out here and become positive, but this negative on top would still dominate, so it would still be negative. So if it was either one of these options, your second derivative would be negative, okay? So straight away, I know those two are incorrect, okay? Now, we've been given these other ones here. Now this symbol here means it doesn't include 0. This one means it does. If I include 0, so if I go x equals 0 into here, f double dash of 0 would be 0 over 1, which is just 0. Okay. Now this does not mean it's concaving up. This just means that's the point of inflection. So here we're not going to include 0. So that can't be the correct answer either. So the correct answer would be C. So when x is a positive value, this entire term will be positive, indicating that concave up. Okay? Alright. And that's about it for this question. You have to have a bit of understanding with the conception. It's not all calculate. Most of it is conception with what the symbols mean and pretty much what we're actually calculating. So when you're learning this stuff, try and focus on the idea rather than what to actually calculate. Okay? Because most of the time, or some of the time, you'll get a question like this thrown at you where it requires a bit of thinking. Okay? Righto, question 5. The graph of the second derivative is shown. Which of the following could be the graph of the first derivative? Okay, so if we have the second derivative here. If we want to go back to its first derivative, we need to integrate with respect to x, okay? Now clearly we have a quadratic here, okay? So if I were to integrate a quadratic term, it doesn't matter what the coefficients would be, it will turn into some sort of cubic, okay? So straight away, looking at my answers here, I know that's incorrect and that's incorrect, okay? It has to be C or D based on the general structure of what you're going to get given, okay? Now here, we need to compare the gradients of these two here because it could be either of them, okay? Now notice here, these will be the turning points of f of x, okay? Because if we think of a normal function, so let's say we had, I don't know, this here. So let's say this is f of x. These guys would be the x-intercepts of my first derivative, okay? Now the same rule applies with the second derivative. The turning points of my derivative will be the x-intercepts of my second derivative, okay? So we can clearly see here, alright, see at those turning points there? They're both at 1 and negative 1. So that's a key characteristic they both have. It's going to come down to their gradient. Now notice here, this axis isn't y. This is actually f dash of x. The second derivative is positive before negative 1. Then it becomes negative between these two intervals. So between negative 1 and 1, the second derivative is negative. Okay, we want to look for that characteristic. So here, between 1 and -1, my tangent lines are facing this way. Now, if my lines face this way, that is positive. If it faces that way, it's negative. Here, between -1 and 1, it is positive. But R1 here suggests it's negative, so the answer can't be C either. Let's see if D is actually correct. So here, the gradient is negative between -1 and 1, so the correct answer must be D. Okay? So again, another conceptual question. You need a good understanding of what we're actually doing at the end of the day with this stuff here. Okay? So take the time to learn the concept rather than calculate stuff. Okay? Righto. Question 6. A random variable x is the number of successes in a Bernoulli experiment with n trials. So Bernoulli is just another word for a binomial, so pretty much a probability where you have one thing happen or the other thing. There's no other things involved, just two things. E to the probability of P success and the probability of failure Q. The probability distribution of the table X is shown. So we need to work out the values of N, P, and Q to generate this probability distribution, okay? Now, the only term I'm going to pay attention to in this big table here is this first guy, okay? Because that 0 is going to work wonders later on, okay? Now, my formula for binomial probability, okay? Probability that X equals something, let's go R, is going to be N, choose R, times by the probability to the power of R times by 1 minus the probability to the n minus R. Now 1 minus the probability is the same as their Q, okay? It's the complementary, okay? Now here, we need to work out what N, R, and P is. Now Q is just the complement of that. So I've just written it like this. You can write it as Q if you want, but I prefer writing it like this, okay? Now we're only going to pay attention to this guy here. So what we're going to do is literally just substitute these answers here and see which one of these gives correct or incorrect answers, okay? Now this will be really easy to evaluate because of that 0 there, okay? So here we'll use the first one. So we'll go 4, choose, and what they've said for R, let's go, oh yeah, be 0, so 0 times by 2 over 3 to the power of 0 times by 1/3 to the power of 4. Okay, so here, this 4 choose 0 is just going to be 1. That's just going to be 1. So that would just be 1 over 3 to the power of 4. And then we can evaluate that fourth. So we have 1 to the power of 4 is just 1. And then 3 to the power of 4, that would be 81. Okay, so straight away we've gotten the correct answer. But we need to check if all these other ones work or don't work. Okay, now notice, it doesn't matter what I'm going to have in these spots here, whether it's a 4 or this. Because I'm using that first term, these front terms will always be 1. Okay, so for the next answer, all I need to work out is, alright, what is 2 on 3 to the power of 4? So 2 on 3 to the power of 4 will not be equal to 1 on 81. Okay, so I know that one's incorrect. Now here, I have to work out, alright, what is 1 to the power, 1 on 3 to the power of 5? And I know that won't be equal to 1 on 81, okay? And same here, 2 on 3 to the power of 5, that will not be equal to 1 on 81, okay? So how I answered this question here is I chose a very important term in this table. I don't even care about the rest of the terms. I chose this point here because it was going to make it significantly easier moving forward, okay? So choosing this guy, a 0 will help so much, okay? Because those first two terms, it doesn't matter what is here and what is here. Because I'm choosing 0 and I want to get this answer, those will turn into 1 instantly. So the correct answer would be A for this guy here, okay? Any questions about this one, leave in the comments, all right? All right, let's take a look at question 7. So finally, an easier question, okay? Those ones are actually quite tricky. Now, I'm not doing this straight raw. I did the test before this. I only got 9 out of 10, unfortunately. I know it's a terrible result. But you've still got to know this content pretty well at the end of the day. Now, with this one here, this is just a straight up power rule here. So if we're integrating 2x plus 3 dx, and you have the bounds 1 and 3, add 1 to the power, divide by the new power. So here, that would be 2x squared over 2 plus 3, and then you've got the bounds 1 and 3. The 2's cancel out, so you'll have x squared plus 3x, and the bounds 1 and 3. Chuck in the first one first, so we have 3 squared plus 3 times 3 minus 1 squared plus 3 times by 1. So here that will be 9, and that will also be 9, so it will be 18. This will be 1 plus 3, so that's 4 minus 4, so the correct answer would be 14. Okay, so the correct answer is C. Alright, right, so question 8. Continuous random variable x has a probability density function, the mean of x. So if you're given a probability density function, remember your expected value or your average will be the integral from your two bounds. Now it's written as negative infinity to infinity of x times by whatever your function is. Okay, so in our scenario here, e of x, your expected value, will be the integral from 1 to 3 on 2 of x times by 3 on x squared. Okay, now this seems tricky, but what's actually happening here, if you have x times by 1 on x squared, that cancels out with one of those. So what we're actually evaluating is the integral between 1, 3 on 2, 3 on x dx. Okay, you can take out the 3 if you want, or you can recognize that'll be 3 ln x, and you've got 1 and 3 on 2. Now I'm going to rub out these guys here because I'm running out of room very quickly. So here you'll want to chuck in the first bound, so that one will go into there. So you'll have 3 ln 3 on 2 minus 3 ln of 1. Remember, natural log of 1 is 0, so that's gone. So the answer will be just this. And we can simplify this to make it match one of these guys here. So notice here they have this guy here. That's our number, but we're missing a 3. So we can put the 3 up here. So we'll have 3 cubed on 2 cubed, okay? And that will be, what's that, 3 cubed, 27 over 8. So we can see the correct answer would be B, right? And that's how you do that one, okay? Right, question 9. Now this one is actually the one that got me when I actually first had it, okay? And I'll show you why. It all had to do with reading it. So, a basket contains 10 green apples and 30 red apples. 3 apples are drawn at random from the basket with replacement. Determine the probability that exactly 2 of the 3 apples are green. Now when I first did this, I knew this was binomial because it's green or red. I thought the n was 40. So those two add together. But notice, the only reason they've given this guy here is to work out the probabilities of green and red. Okay. Now exactly 2 of the 3 apples are green. The probability that it's green will be 10 over the number of apples, which is 40. So it's just going to be 1/4. But notice here, we're only taking out 3 apples. So your n for your binomial is only 3. And your r would be 2. That's where I got this wrong. Okay. So here, probability that x is equal to 2 out of the 3 would be 3 choose 2 times by 1 on 4 to the power of 2 times by, and I've run out of room there, so it'll be 3 on 4 to the power of 1. Okay. Now here all we have to do is work out this guy here. So if we're doing 3 choose 2, that'll be 3 factorial over 2 factorial times by 3 minus 2 factorial. So here, that's just going to simplify. I think it's going to be just 3, because 3 factorial is same as 3 times 2 factorial. That'll cancel out. So we'll just have a 3 on top. Then we'll have 1 factorial, so we'll just have 3. So 3 times by, distribute the squared, so times by 1 on, and that'll be, what's that called? Well, I'm having my mind blank. 4 times 4, 16. Okay. Then you distribute that 1, so times by 3 on 4. So now all we have to do is work out this fraction. So 3 times 3 is going to be 9, and then 4 times 16 is going to be 64. So the correct answer here would be B. Okay. Righto, 10. Final question of this little test. It's taken 19 minutes, but you've got to remember I was explaining it as well as I was going through it, okay? So usually it's about a minute per question, but realistically some of these questions will take more than a minute, some will take less than a minute, okay? So 10. Handspans of teenagers are approximately normally distributed with a mean of 15 and a standard deviation of 2. Which of the following groups is expected to be the largest? So here, our normal distribution, the biggest area will be between one standard deviation of the mean. So the mean is here, one standard deviation forward and backwards. That's going to be 68% of the data, okay? Now here, the mean, what did we say? Oh, 15, and standard deviation is 2. So between 17 and 13 will be the largest. So all you do is take your mean, add the standard deviation, that's where I got my 17, so 15 plus 2 gives you 17, and then I took the standard deviation away, so 15 minus 2 gives you 13, okay? So here, if they give any answer between 13 and 17, that's the correct answer. And we can see straight away C gives that answer. These other ones are valid, but they're not as big as this, because it's normally distributed, okay? And that's about it for this test. Overall, nice little test. A lot of these were conceptual questions rather than calculate questions, so make sure you are pretty good at pretty much most of your content, both calculating things and conceptual, okay? But overall, I'll see you probably in the next video. I'll probably do paper 2 or the short response next. See you later.